How many moles of oxygen do you need? 5. So see, that's good. You see, if John had a tank of methane in his backyard, okay, and Bella had a tank of propane in her backyard, and they cooked the same amount of things, who would run out of gas first? Huh? John would, right? Because John's only using a little bit of oxygen to methane, and actually a 1-to-2 ratio. But look at Bella, she's using a 1-to-5 ratio. So she's going to get 3 times the amount of bang for her buck. You see, that's why they put propane, one of the reasons why they put propane in a tank. All right, because you do not have to fill it up as much. Now, what do you think as you get higher and higher? Look here at this butane lighter. Which one's going to be more efficient, butane or propane? What's that now? Butane. Well, what about octane? You've heard of octane racing, right? Well, why wouldn't you put octane inside your propane grill?
Is it liquid?
Well, it is a liquid, all right, which would be more hazardous. But it would be almost like an overkill. You know what I mean? It's just like that. I love Richard Pryor. And he was in a movie one time about his neighbor. Okay, John, me and John's having a conversation, right? Some of you guys don't even know who Richard Pryor is probably. But he's in a movie about this, his neighbor's got this lawnmower, but it's not a lawnmower. It's got like a diesel engine on it, you know, souped up racing thing that makes all kind of noise, and it's an overkill, right? All right, so let's look at this one. Let's balance this guy. 4 carbons here. How many do we have over here? 4. Okay, 10 hydrogens. How many we got to have? 10, so what do I got to put here? 5. Okay, let's do an oxygen count. How many total oxygens we got on this side? We have 8 coming here, right? And how many do I have coming out of this one? So what's 8 plus 5? 13. Whoa. Well, what are we going to do about that? What number times 2 equals 13? Huh? What do you mean, uh-oh? What number, when multiplied by 2, equals 13? X equals 13 divided by 2, which is the same thing as 6.5. You with me? Okay. So, we can put 13 halves here. We can put 6.5 here. Is there anything wrong with that? No, not really. No one says you can't have a fraction up in here. And matter of fact, whenever you look at thermodynamic tables in 2 chemistry classes from now, it's very common to see fractions here because they base everything on 1 mole. Now, it is chemical etiquette, unless you are doing thermodynamic tables, to not have fractions. You don't want that. Okay? So what can I do to fix it? Well, this thing here is just like a math equation, where that's an equal sign. So let's just say, for an example, that I have 3x equals 4y. And let's just say that I multiply, okay, so that's an equation. Let's say I multiply everything by 2. I would have 6x equals 8y. Is there a difference in these equations? No, they're not. But here's the key. You can multiply an equation by anything you want, but you got to do what? You got to do it to both sides all the way through. You can divide an equation by anything you want. Well, chemistry is the same way. What can we multiply this by to get rid of that fraction? 2. You with me? Because if you got 13 divided by 2, if you multiply that joker by 2, what you going to get? 13. No fraction. Let's see what happens when we do that. And we'll still be able to check ourselves. Let's see here. 2 C4H10s plus 13 O2s yield 8 CO2s plus 10 waters. Alright, so for some of you skeptics, let's take a look. Let's divide this thing in a left-hand and a right-handed side. How many carbons we got over here? 8. You see how that's 8, not 4? You ever said that?
I didn't mean to.
You didn't? I understand, right? And then here you've got how many carbons? 8. Sorry. How many hydrogens you got here? Uh-oh. See how bad did he? See how confident you can be? 20. And what do we got over here? 10 times 2 is 20. And oxygens, how many we got? 13 times 2, which is 26. And how many oxygen we got over here? Well, there's 10 coming there, and how many is coming out of here? So 16 plus 10 is? Do you see how we're mass balanced? It doesn't matter how you do it. Here's what matters. When you're done, you can get these check marks off of there. All right. So what ratio are we doing here? This is a 2 to 13 ratio. So burning that butane lighter is more efficient than burning a propane grill. All right. Shall you guys try a couple? All right, well, I'll put these two up on the board, or these 2 or 3 up on the board. We'll turn off the camera and let you tinker around.